perpendicular lines. So, to start off, we want to look at these pictures and determine which ones would represent a perpendicular bisector. Now, by definition of perpendicular bisector, the perpendicular bisector is a line perpendicular to its segment at its midpoint. Okay, so you don't have to write these down, but you can see this first one. It crosses through the midpoint. We can see that that's the midpoint because AM is congruent to MB, but this is not, that's not perpendicular, so this one would not be a perpendicular bisector. Now the second one, the line intersects line CD at a right angle, and so this is perpendicular, but the length of C to this point is not congruent to the length of that intersection point to D, so it again is perpendicular but not a bisector, whereas this one was a bisector but not perpendicular. This last one, it's perpendicular because it forms a right angle, and if we call that M, EM is the same length as MF, we can see because this is marked, so this one is a perpendicular bisector by definition of a perpendicular bisector. Okay. Now, if we were to come down and look at example 2, like you don't have to write this one down, but what would be the shortest distance from line A, from point A to line T? The shortest distance is always going to be perpendicular. Okay, so the shortest distance from any point to a line is always going to be perpendicular. So from here, I do want you to start writing at this point. Okay, the first thing we want to talk about is you should have already written down your theorems in your theorems list, but the perpendicular bisector theorem, you have definition of a perpendicular bisector which says a line is perpendicular to a segment at its midpoint. So we have draw line A parallel to line B. So go ahead and draw line A parallel to line B. Now I'll go ahead and label those. This is line A, this is line B. Now we're going to draw line C parallel to line B. So if I drew another line and called it line C, and we knew that A was parallel to B and B is parallel to C, then you can see that this implies A is parallel to C. So essentially, if two lines are parallel to the same line, then those two lines are also parallel to each other. Okay? That's the theorem you've just shown. From here, we want to draw line R perpendicular to line S. So if I drew line R perpendicular to line S, and I'll label those R and S. Now, we want to draw T also perpendicular to S. So if I drew T, and we knew this was perpendicular, we knew R and S are perpendicular, T and S are perpendicular, well now you can see that those are corresponding angles and they're congruent. So if corresponding angles are congruent, then you know that line R is parallel to line T, so this implies that R is parallel to T. Now this tells us our perpendicular transversal theorem. Okay. So this tells us that two lines perpendicular to the same line imply parallel lines. So we know R is parallel to T. That would be a reason. So we have one last one on exploration. This one tells us to draw line N parallel to line P. So I'm going to go ahead and draw line N and line P. Now, I will label those line N and line P, and we're told that those are parallel. Now, we're to draw line Q perpendicular to N. So I'm going to go ahead and draw line Q perpendicular to N. So we know that those form a right angle. Well, if N and P are parallel, then this angle is a corresponding angle with this one, and if lines are parallel, then corresponding angles are congruent, so this must also be a right angle. So this tells us that if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So we know that Q is perpendicular to P. Okay? So again, this would be your reason. This is under your perpendicular transversal theorem on your theorems list. So from here, we're going to go through one proof using some of these theorems. So in this proof, you're given, this is actually part of your given statements. So you're told that this is an example given both of those. So we start off, you're given that angle EHF is congruent to angle GFH. So we'll write that. Angle EHF is congruent to angle GFH given, and we want to mark our picture. So angle EHF is talking about this angle right here, and angle GFH is this angle right here. Okay, now at this point it's hard for us to tell what that's talking about, so what I would do is go ahead and highlight or do a color on your parallel lines so we can see on those two angles, this line EH and line FG, those are your parallel lines. Again, you can always extend the lines. Now your transversal is FH. Okay, this, if you extend the lines, it will give you a better idea of what you're looking at here. Okay, so now we can see that those two angles are alternate interior angles. Well, if the alternate interior angles are congruent, then you know that EH is parallel to FG because congruent alternate interior angles imply parallel lines. So we know line EH, or segment EH, is parallel to segment FG because congruent alternate interior angles imply parallel lines. And again, go ahead and mark your picture. Okay, from here we don't know anything else, so we can go ahead and move on and say FG is perpendicular to GH, are given. Segment FG is perpendicular to segment GH because it's given. And we know that perpendicular, FG and GH, that tells us that those form a right angle right there. Now we're supposed to prove that EH is perpendicular to GH. We know these lines are parallel and GH is perpendicular to FG. Well, based on our perpendicular transversal theorem, we know that if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other line. So we can say EH is perpendicular to GH, it's a G, because of our perpendicular transversal theorem. Which basically says if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other line. Okay, that's one option. Now your other option is you could say, well, these two lines are parallel, so this angle has to be congruent to this angle. If they're both right angled, if this is a right angle, then those are perpendicular. It would just take more steps, but it wouldn't be wrong.